right, seems it's time to start. Thank you for coming. Not as full as the other ones. It's fine. Zach did a great presentation, by the way. Welcome to our talk about DITTO, a hybrid IAM system for microservice architectures. It was developed at real.digital, and I want to talk a little bit about what real.digital is. I mean, I hope you guys have seen or know, if you're German, that there's a supermarket called Real, right? Good. So real.digital is basically the IT group of Real. We do the e-presence of Real. So we are like some sort of like mini Amazon, and we also are building cool stuff. So we are aiming to get, AVS one day. We are today in 21 million visitors per month. Some interesting data, right? 5,000 retailers, 15 million products for 5,000 plus categories. Located in 5 locations, around 200 developers. So just a bit of like, what is real.digital? Many of you might not even know that Real has an e-commerce page. Oh. Good. But then about us, my name is João Oliveira, Dr. João Oliveira. I don't get to use the title that much. I'm team lead for the platform, microservice platform at Real. We have been working on this for a while now. I have some colleagues here in the audience. And with me, I have Joschka Tillmanns, former coworker, software engineer and co-founder on Mooncamp, a company based in Cologne. All right, our agenda today is going to be a little bit about IAM. All right, let's understand a little bit what that is, and then talk a little bit about API gateways, how they do IAM. Another topic, OPA, Open Policy Agents, and then we're going to talk about DITTO, right? Like how it sits among these 2 ideas. All right, we're going to start simple. Right? Our story starts very simple, with a cookie, right? Delicious cookie. That's equivalent to our resource, or whatever we want to manage, right? Usually when we're doing microservice, we wanted to surround this production and consumption of our cookie through a service, a jar, in this case. And we want to make sure that the right people are actually able to handle these cookies, right? Like just the baker guy goes there, like produce a cookie. The right consumer goes and buy a cookie, get to eat a cookie. Not really this guy. We don't want this guy. This guy is not the one that we want to eating the cookie. So Wikipedia definition, Identity and Access Management, or IAM, is a framework of policies and technologies for ensuring that the proper people in the enterprise will have access to the right resources, right? But in summary, we're discussing who can do what to what data, right? So we already saw that the little guy there, we don't want to have access directly to the cookie. We want him to be firstly identified and see if his identity actually has some permissions to access this cookie. So let's talk first about what is this identification. We call it authentication. It's a process of actually just verifying if the identity of the user is correct or is who he says he is. So there are several ways to do that. Like one very common way web-wise is login password. But you can have fingerprints, in your apps, client credentials, API keys, or just a badge. Many of you have badges today. That's also a sort of authentication. And after we have the authentication, we have to see if this user has authorization. And authorization is a function of specifying access rights to a given, or privileges to a given resource. So I guess many of you already know, like role-based access, for example, or attribute-based access. If I am the team lead, I am allowed to add members to my team or remove members to my team. Sort of role-based access control. There's multiple ways actually to achieve IAM, and we're going to discuss basically 2 approaches here, besides the DITTO one. All right. The first approach comes through the pattern of API gateways, right? First of all, API gateways, they are much more than for IAM, but we focus on authentication and authorization part. What happens here is that a user, he needs to access a certain resource, for example, the cookies.real.digital. But he doesn't have access to this direct resource or services. He will access this service through an API gateway. So he will query the API gateway, which it will relay the request to getting the identity of this user, check if this user is authorized, and finally, if everything goes all right, it goes to the cookie jar or to the candy jar, and we will return the request with like a valid response. Not talking about pros and cons of this approach, but the characteristics. It will be a single entry point, proxying all requests to internal services. You're going to manage access control while doing the proxying. You need to have the services APIs being registered to the gateways. And it's a fairly centralized approach. You see a bunch of vendors going that way. You have Amazon API gateways, you have APG, you have Tick, Kong, Zool, Netflix, and much, much more. I guess we even have a talk at ContainerDays for API gateways. All right, this is a very centralized approach, and in the other side of the spectrum, we have OPA, which is Open Policy Agent. It's quite the opposite. It's very distributed. And the way it does happen, it has been a couple months since I last read the OPA documentation. So if anyone in the audience is from OPA, just like, I hope I'm making a good summary of it. The way that it happens is that it's fully distributed through sidecars. So whenever I have a service, I launch together a sidecar, and I declare my policies on this sidecar, right? Through a very powerful declarative language called Rego. And then whenever I need to do a request, it goes through the sidecar, and if everything goes right, then it goes to the services, the service respond, and then finally, where's my cookie? Oh, got it. Good. One of the situations that arise from that you have storage and enforcement of these policies directly in front of the service, right? So whenever I'm doing policies here, I have them stored on that storage that the sidecar is using. One potential challenge that I see with that is that managing policies across several services can be a bit tricky. Imagine if I have to delete a user and delete policies in a lot of services transactionally. Also, the documentation encourages us to expose service data and the relationship of those. And it's a bit iffy for me. But we're going to talk a little bit about DITTO, and DITTO, how it actually sits a little bit in the middle of this scenario, like centralized approach, distributed approach. And I'll leave my colleague, Yoshi, to do it.
All right. Thank you, John. So I hope you're ready to hear about a little bit unconventional software that we developed at Real to solve this IAM issue in a little bit different way than typical API gateways or OPA would solve this. So the word DITTO actually comes together from different words, which is distributed identity to token orchestration. And this a little bit describes the history behind this software and how we built it up. So it's actually a set of tools that ensure us this IAM system. So first of all, we started with identity management. So we had to have some service that defines us if someone is registered in the system or not. So we wrote an identity management service and called it identD. And this is where the identity in this word comes from. Then we go down and wrote a service which provides us the policies that describe what a given user can do or cannot do. And we actually called it TokenD because it builds out token that describes the policies. And this is where this token comes from. And in the end, there has to be a client who speaks to all these services. And in order to provide an easy and simple way to do this, we wrote an SDK. And it altogether describes an orchestration. And this is where the last word comes from. All right. So it is written completely in Go, which brings all the nice and cool features of Go with it. And it's actually a federated identity management system. So what does that mean? It just is a fancy word for saying our identity provider can actually talk to other identity providers. So it can go to Google or it can go to Facebook. Currently it is implemented to actually call to some of real native identity providers, which would be Rosso or CAS. But it can also go to a local Redis storage to kind of manage their own identities. All right. It is based on policies, of course. And this is where it stands apart a little bit from the other IAM systems. I'm going to go into detail into this in a few slides. But yeah, it has basically a centralized storage like you would find in an API gateway system of the policies, but unlike in an API gateway system, it does actually the enforcement distributed. It's heavily based on JSON Web Tokens, and it is stateless. Stateless, not in the sense that there's no state, because it has to have some state in order to store, of course, the user policies, but the actual enforcement requires no state. So whenever you do an enforcement of policies, or whenever you check if a user actually can do something, you don't need to call a database. All right, let's go into more detail into how this all works. Actually, no, I'm sorry. One thing first. DITTO actually is built with one concept that we really care about. So DITTO really takes care of developer experience. It takes developer experience extremely serious. So the goal behind the system is basically that we can deploy this at real into all teams, and that every dev can understand and use it. The thing is, security can be extremely overwhelming, and we want to take the developer at his hand and care for him so that everything doesn't break. DITTO is doing this by providing a design that treats developer experience as a first-class citizen, and it brings security by default. It's doing this by requiring minimal effort such that all endpoints are actually secured. And it's doing that on top of that with additional tools and an SDK that makes enforcing security requirements very easy. Okay, now into how this actually works. All right, this slide describes how a typical workflow with DITTO would go. We have two very important parties here, actually. This is on the left side, the cookie lover, and on the right side we have the cookie jar. And of course the cookie lover wants to access the cookie jar, but the cookie jar wants to stay protected. So before anything of this can happen, it actually publishes rules that have to be defined. And these rules say, for instance, if you want to access the /cookies endpoint, you have to have a policy that states that you can access the resource cookie with the action bake. So this is what the cookie jar publishes before anything of this can happen. And then let me go through the steps that are required for the cookie lover to actually access the cookies. All right. First of all, it goes to the identity manager, or the identity provider, I'm sorry, and it identifies itself. So, and whenever someone is registered in the system, it actually gets back an identity token, And this is like the normal JWT, so JSON Web Token that you would find. And it holds that token, so it basically caches the JWT. When it actually received the ID token, it can go to TokenD, which, like I said, is the resource policy provider, and can ask for TokenD to bring back a resource policy claim or a permission to actually access the service. If the cookie lover actually has access to the resource, it is happy to sign the resource policies and return it back again as a JWT. What the cookie lover again does, it holds the JWT, so it caches it, and can now finally go to the actual service, which is a cookie jar in this case, and show the signed resource policy to the service, and the service can then check whether or not the signature is correct, and as well if this resource policy contains the necessary information, which in this case is resource cookie and action bake. Right. So this maybe sounds a little bit complicated, so let's go a little step deeper. No, sorry. I want to emphasize some more interesting points to this. So we can see that like all the communications between the parties is trusted because of the signing work. I have to emphasize that if the cookie lover doesn't actually have permissions to access the resources, it gets back an empty JWT. And if it would then use this empty JWT to access the cookie jar, it would get a not allowed HTTP response. So the token always signs something, but if you don't have permissions, something empty. And the thing is that here we are doing one request, of course, to eat a cookie, but you could use the same token to eat 1 million cookies, and you don't have to connect to identity or TokenD again. So this makes this process very scalable because you only have to talk to the parties once, and you can kind of define in what time range the client, or in this case the cookie lover, can do these requests by using the expiration date feature or property of JWTs. So in a typical scenario, you would get an expiration date of maybe a day or a week for your identity tokens, and then maybe 5 minutes for the tokens that are responded from TokenD. All right, off to the next step. So like I probably repeated 5 million times already, resource policies are the core data structure that we find in DITTO. So they are very much AWS IAM policies inspired. So if you've ever worked with AWS IAM, you maybe find similar properties in this. And what this does is actually it gives you very fine-grained control to a single resource. So, of course, I talked a lot about already about the resource and action properties. So this resource policy states that whoever is holding this may consume the resource cookies with the action eat. But there are a couple of more properties in this. I want to talk about scope because it restricts the data set. And in this case, it means that the cookie lover may only eat macadamia flavored cookies. Additionally, you can also enforce some runtime checks. So in this case, we have the runtime check date until, and it says the cookie lover only may eat cookies with flavor macadamia until today. All right, so let's go into more detail on this. Like I said previously, the history of a request is kind of the same. So first you do your signing against token D, and then you use the actual JDT that is responded from token D to go against the service. But what is kind of new in this is that you can define a query against token D, and this query allows you to specify on a very high detail what you want actually signed from token D. So let's make an example. I do a query where I only define the resource property, and I say resource cookies, and then token D would sign me all my resource policies that have the resource cookie. And I can make this more explicit as I want. Right, and then I, of course, take this JDT and go against the delete cookie, which would be it in this case, and then everyone is happy. So, at this point, it is clear that there needs to be some logic in every service in order to verify that the token is correct, or that I do have permissions. But what we can actually do is lift this up to the service mesh layer, and therefore don't implement anything in the services, and kind of do this all through infrastructure. So let me go into more detail on the next slide. Like I said, of course, the verifying of the token can happen in the app. However, like I said in the beginning, the enforcement is actually stateless. So all the data that is necessary to verify a token is already in the token itself. So you don't need to do an extra data request. This makes it very easy to implement this thing in the service mesh. DITTO actually comes already with an implementation for Istio, and this works like the request gets proxied to the sidecar, and then there is an Istio adapter that checks the token, and when the token is not correct, it's actually blocked before it even reaches the service. So whenever you don't have permission or the signature is not correct, you wouldn't ever even receive the request. If it is correct, of course, it's just forwarded to the service. This, of course, means that you can save a lot of code inside your services, because all of this logic can go to the service mesh. All right. As a second step, of course, you also need to inform the data filtering that is defined by the scope. So like I said before, of course, the resource and action is used to verify that you actually have access to the endpoint. But on a second step, you of course want to also restrict the data that is given access to. So what you would do in a typical scenario, you would take this flavor macadamia and you would inject it into your SQL statement. However, we recommend that you use a typical like ORM filtering tool. There are implementations for prominent ORM tools like Doctrine and Hibernate, and this is what we are also actually doing at Real. All right, let's recap a little bit and look at what we actually have to do in order to use DITTO. So we, of course, have to, first of all, deploy the services. In this case, it's ident and token-D and the DITTO Istio mixer adapter. And then you have to kind of, for each service, so you only have to, of course, deploy the services once, but then for each service that you want to add and integrate into this DITTO system, you have to do this two-step plan. So first of all, you have to define your API requirements, which say, and I repeat myself, like define the resource and the action. And then you have to deploy the Istio manifests that couple with these API requirements and enforce the rules. And let me, so this is not so magic, give you an example of such an API requirements. In this case, we want to secure two endpoints, which is cookies with a method post and cookies with a method delete. And what we are saying is we have a requirement for the post method endpoint that you have to have access to the resource cookies with the actions bake, and that you have to have for the delete endpoint permissions to access resource cookies with the action eat. All right, and now I want to give back to my colleague.
Right, so for our closing remarks, I hope you guys will take away some things that are from this presentation. First of all, a little bit of IAM. For those that are not doing anything with IAM, this is some options that you can be looking for. I guess one of the main takes that you can take is some food for thought. I guess many people are doing IAM directly with API gateways, and and they are taking that for granted. This is the solution, and there's nothing else to do. And we like to challenge this idea, right? After we had the idea of DITTO and we started working on it, we scoped the area and we find OPA on ContainerDays, I guess last year. I'm not sure now. But we like to do something different. We like to provide different solutions, see if there's another option, right? And that's how DITTO came to life, and it's actually being used in production. One thing to be clear is that DITTO definitely is not the silver bullet of IAM. Very, very far from that, right? But it contains some interesting ideas, so I hope you guys can take one or two if you're doing something with IAM. That's it for our presentation. Thank you very much for attending. I hope you guys have some interesting questions for us.
So once you have acquired JWT token from your token D, do you validate the token expiry part also in the your service mesh layer?
Definitely, yes.
Token has expired. What actions do you take? Do you refresh it automatically, or you unauthenticate the request?
Well, we just do cancellation. The request is expired. I mean, the expiration date of the token is already gone. We just return a 403 with also the a message. And given that we can create a response with the adapter that has even a body, like a JSON body, we could eventually read this body and do a re-request of the token. It's interesting to say first that this can happen. This definitely can happen, but it is a small chance because before you even you cache this until the expiration date. So you have maybe 500 milliseconds in 5 minutes, 10 minutes to have this problem, right? Because of this.
My question is whose responsibility is to refresh the token?
You need to speak louder.
Whose responsibility is to refresh the token? It's the client or some part of your service who can actually refresh the token?
We keep this responsibility at the client level, yes, as also caching the token. We do that through the SDK.
Okay.
Did you use protocols like OpenID Connect and OAuth? And if not, why not?
I'm sorry, it was a bit low.
Okay. Did you use protocols like OpenID Connect, which is one protocol for using the problems you described, and another protocol for using these kind of problems, but it's targets to to delegate authorization is OAuth. Did you use these protocols, and why? And if not, why?
All right. Yes, we actually use internally in as you guys heard, we do have two services running. One is identity, and the other one is token D. Identity is a lot. There's a lot of things with OAuth on it, actually, because it is a federated identity manager. So it does talk to Google. It also implements the OAuth protocol for credentials that are stored locally, so it can serve identities as well. There is one detail. OAuth has scopes, for example, right? Like email or profile, but this is like one string. I don't see this increasing to a resource policy complex like this one.
You're completely free to define your own scopes. So, and it doesn't contradict to have a known policy to do whatever you want with these scopes. So you can define your scopes, your claims in your token, in your JSON Web Token, for example, and you can still have your policy which enforces your whatever you want to achieve.
You're saying that like I could create a scope with complex object inside. Is that it?
Sure, you can define whatever you want, and you're completely free to define your own claims in your JSON Web Token. So, and also to define your own scopes.
Well,
it's up to you from the view of the specification.
Yeah, that's a good point. I think I would have to look into a little bit more to make sure if I did something wrong on the design of this.
When a permission gets denied from a user, so it gets removed, the token will still be valid, right? Or is there some custom blacklist for tokens for permissions which got deleted from the user?
So yeah, you like I said, or like John said before, there is this time range of like 5 minutes. You can, depending on your security needs, you can of course lower or widen this range. But if you take away a permission to some user or some service, and it still holds the token or the resource policies, the signed resource policies, of course, he still has permissions within this time range. That's why we like enforce. Like it depends on the security like needs that you have. If you want to enforce really strict sort of like security measures, you can of course set this thing to, I don't know, 20 seconds, and it's still performant enough to like do signing work for, I don't know, we calculate the numbers, but I guess like 100,000 to 200,000 sort of like clients from one node. So yeah.
Okay, thank you.
All right, it seems we don't have more questions. So thank you very much. Have fun in Container Days.